All right. So when we talk about Rx, we often talk about observable collections. And why is that? So, well, because these things are really like collections. So guys, why don't you come here and let's draw some of these beautiful marble diagrams.
Sure. So Jeff, what is a marble diagram?
Yeah, what is a marble diagram?
As collections are observable and reactive, they don't just contain data, they also have a time aspect to it. So the values come in over time. So what we usually do is we draw on the x-axis, we draw like a time. So time goes that direction. And then the operations that we do on the collections, we draw on the y-axis. So we start with the top is the original observable collection, and then at the bottom we draw the manipulation we do to this. So imagine that you have a select operator on your observable, which takes an original observable and transforms each value into a new value. So imagine that the original has like these nice round marbles over time.
And those represent on next messages.
So imagine that 100 milliseconds is first round marble, and after 2 seconds we get the second. Now select, what it does, it takes each of these values and executes the handler, and imagine that it makes it into triangles. This is the execution of the handler select, and then it projects those triangles to the other observable. Yeah, so you would read this. This is the original observable with the values on it. Here in the middle is where the transformation happened. This is the output of the observable. You select.
So now, Jeff. So how would like where look like as a marble diagram? So
Sure.
Suppose we have like marbles that are big and small, and we want to have only the small ones in the output.
Sure. So I'll leave this one on here.
Yep.
Another one here. So imagine this is the source, and we have small round marbles, and we have big marbles. Another small one here, and the where says like where marble is big. So this one comes in to the handler. The handler says, no, this is a small one. I'm going to ignore that. Then this one comes through, and the handler says, oh yeah, that's a big one. I'm going to allow that. It projects it to the other one. And the small one comes in and gets ignored again. That's how you draw a marble diagram for where.
These marble diagrams are awesome. They deal with on next messages is great, but there's one shortcoming we have so far in the marble diagrams. They don't deal with on exception or on error and on completed. We can extend our marble diagrams just slightly with some new notation. We'll draw it actually below here. So again, we have time going here along the x-axis. We have values coming in at various times. Now, how can we denote an exception? Usually what we've done is denote an exception with an X, which means that this observable collection, sometimes we also call them observable sequences, is terminated abnormally with some exception.
And if you remember, exceptions can only happen once. So at the moment that scene X, the collection is dead.
That's right. In fact, another useful thing is to think about these things in terms of what we would expect from renewables. If you point over a renewable like this, you get some value, some value, some value. Then we call move next here and throw an exception. You wouldn't expect it to be able to keep iterating over at that point in time. Another thing is you could also include this normal. So the same thing, 3 values, and then we say, I'm done. So compare these 3 different lines. The bottom line represents an observable collection or sequence that contains 3 different values, 3 different on next messages, but does not terminate. The second one down represents an observable collection or sequence that terminates normally. This one represents one that terminates abnormally with an exception.
So that is really nice, Wes.